Welcome to the Solid Oak Technologies CoverAll Design Intent Capture demo. During this demo, I'll demonstrate how easy it is to import a legacy timing diagram into CoverAll. In addition, I'll demonstrate how to generate the assertions and sequences required for assertion-based verification. Timing diagrams are typically used to show the timing relationship between signals on a module interface or to show how data is intended to flow through a module. For this demo, I'm going to use the VCD simulation file captured from the OpenCore's I2C controller project revision number 57. Here's a waveform that I captured after running simulation on the I2C module. And I've selected a small portion of the simulation here. You can see between the green cursor and the red cursor. And what I'm going to do is I will recreate this for you and show you how we got to this file. First of all, here is the VCD file that was generated. I'll open this with Vim. You can see it's a standard VCD file. Variables here, and then your simulation text below. So if I open this file again, here you see the simulation, and what I want to do is I want to capture the area between the green cursor and the red cursor, and I want to capture the following signals you see here on the left side of the diagram, which is basically the wishbone interface. So I'm capturing a couple of write cycles from the wishbone interface. So let's open up Visio. So here's a Visio instance, and I'm going to open a blank drawing right here. So I've created a blank drawing, and now I'm going to switch to landscape mode. Okay, so I have a landscape drawing. Now what I want to do is import this particular design into a Visio drawing. And the way that I do that is I invoke CoverAll, bring CoverAll up here. All right, here's the CoverAll shelf. On the second tab here, you see Import Diagram. CoverAll can import VCD files, or it can import XML files. So today we're going to import a VCD file. And we're going to import this same VCD file I just opened and showed you on this figure right here, which is the I2C underscore testbench.vcd file. Two things to note here. I'm going to be placing this particular in this text area, I have to define which diagram. You can browse to that diagram here on the computer. Go to the desktop, and you can see here's the I2C diagram. And then you have to define a log file. For this particular demo, I've defined a directory called test2, and I'm going to put the log data into a file called import.log on my C drive. The only other thing you notice here, you can import XML files or you can import VCD files. You can also import them as SVA, PSL, OBLV1, or OBLV2. And the final thing to note is I have told CoverAll to add this to the current document, which is the document I just opened. And I wanted to output this into the same directory as I've defined up here, the test2 directory. Okay, so we can go ahead and run this. What you're going to see real quickly is CoverAll is now scanning the VCD file, and it's collecting information from the VCD file. And basically, it's put the information up here. It put the file name, how many characters it read, how many signals are in the VCD file, the start time for the VCD file, and the end time for the VCD file in megaseconds. And then it's thrown up this dialog here that you can use to enter the information to create this particular timing diagram within Visio. I'm going to call this diagram dummy for now, for lack of a better name, and I'm going to grab these same signals. The first one you want to grab here is the clock signal. You need to tell CoverAll what is your intended clock signal. There's no way for CoverAll to look at a VCD file like this and figure out that this particular signal is the clock. So we have to define that. The second thing we have to do is list all of the other signals that we want to capture out of this waveform. So I'm going to come down here and start grabbing the wishbone signals, and I'm going to skip clock. The way you do this is double click the signal and it will pop over into this box over here. We're almost done. Alright, so I've grabbed all my signals. One of the signals I don't really want, which I did grab, was the reset signal, and I can go ahead and double click that, and you see it'll be removed from this list and put back over here. Now I have to define my start time and my end time. And if you look here, the start time is about 100,915 nanoseconds, and here the end time is about 100,950 nanoseconds. So those are the numbers I'm going to enter here on my dialog. So here I'm going to enter 100915 and change the parameter to nanoseconds, and then 100975 and change that parameter to nanoseconds. Okay, so we're done now. We can go ahead and click the OK button and watch CoverAll bring us into the. I'll pull this up here for you to see. You can see CoverAll is now drawing that waveform inside of Visio for you. Takes a bit while it goes through the file and extracts this data. Okay, so it's captured our diagram for us. What we can do here, if we want to, is we could go back and annotate assertions on here, or we could go ahead and process this directly through CoverAll. But what I'm going to do is just to show you how to do this, I'm going to go ahead and annotate a single assertion on here, and I'm going to put an assertion between the strobe and the WB-ACK signal. And what that's going to do is that's going to create an assertion that says whenever WB strobe comes high in the next clock cycle, you're going to expect WB-ACK _O to go high. Okay, so let's go ahead and process this inside CoverAll, and we have CoverAll already up. So we can come here, and now we can go to our generate options. And I'm going, the things you need to fill in here is you need to specify a log file for this operation, and I put that in the same test2 directory. Only this time I've called the output is waveform is where I want this to go, since I'm going to be creating assertions now. So I'm going to be creating a number of assertions, sequences, path covers. In the case of timing diagrams, you don't generate path covers. So all of this information is going to go into the search directory, and we can go ahead and run that right now, and you'll see what happens. CoverAll's checking the pages. And it's asking us if we want to overwrite this information, and there we go. So CoverAll has now created one assertion from our timing diagram and one sequence of 1, 2, 3, 4, 5, 6 clocks here. I'll scroll this over so you can see that each one of these is actually a clock. Here you can see at the end of each of these statements the pound one, which indicates that we're generating a clock. And here's the assertion that says W strobe. Once W strobe occurs in the next clock cycle, you'll expect to see WB-ACK to be asserted. Okay, so if we go back and look at the diagram here, you can see we have captured all the signals that were in the original VCD diagram. WB-ACK 0 should show up as the first one here. There you see it below the clock. The clock is always placed on the first line. And then all of the remaining signals from our waveform are also placed here. Okay. One other thing I want to show you real quickly is the debug capabilities of CoverAll. I'm going to make these windows a little bit smaller to make it more obvious what I'm doing here. Okay, we can go here and click on this dummy, the TD sequence macro here, and it shows us where that particular sequence occurs within this file. We can also click on the assertion, and you can see that it indeed grabs this assertion down here and tells you where it is. We can also do the opposite. It's just a little bit smaller. It's as small as the window will go. What you can do is you can grab this and ask it to find that diagram object. see CoverAll will grab the dummy text there, and you can also grab this particular one and tell it to find that diagram object, and you can see that CoverAll has grabbed this assertion. Okay, that's the end of our demo. Thanks for watching.